So we're now in the EX8 folder in my Java 8 package under my live lessons GitHub repository. And that's the code we're about to look at for the discussion tonight regarding completable futures. So we're now in the IntelliJ project for this EX8 example. And you can see here that we've got a main driver program, and then we've got a utils directory, and we've got a test directory. And we'll take a look as we go through this at the various pieces that are lurking in tests and utils. This particular example shows how to reduce and or multiply big fractions using a whole range of features in the Java Completable Futures framework. This will include various factory methods like supply async and run async, a whole slew of completion stage methods, both methods that trigger when a single prior phase completes, and also some methods that will, completion stage methods that will trigger only when one or other or both of two previous methods, completion stage methods complete. And we're also going to talk about arbitrary-arity methods and exception handling methods. So this particular example, which I'll probably split up into multiple parts to make them more digestible, will demonstrate lots of cool things about completable futures. This example also shows something else that's important, which is how to combine the Java Completable Futures framework with the Java Streams framework, in particular sequential streams. It's really not a good idea to combine completable futures with parallel streams, but they work very nicely with sequential streams. So you can see there are four main types of tests we're going to demonstrate. One will show off how to use just good old threads in conjunction with completable futures and the fork join pool executor implementation with completable futures. Another set of tests will show the completable future completion stage methods that trigger after a single completable future completes, prior stage completes. Then we'll also show some examples that where there are two methods are, one or both of two things that complete. And then the final thing we'll do is we'll show how completion stage methods handle exceptions. And these are all things you'll need to be able to do for the next programming assignment. Now, we're going to use some interesting helper classes. And one of the things you quickly discover when you start working with asynchronous code, like completable futures, and this applies also for reactive code, is that the whole design, the whole intent is to run things asynchronously. And that often gets kind of complicated because you'll end up having your program, your test program, fall off the end of main before the computations are finished running. And that's really annoying because then you don't get the results. So to make that easier, I wrote a little helper class called Async Tester. And this class will asynchronously run tests that use the Completable Futures framework. And it'll also provide some cool methods to ensure the test driver itself does not exit until all the asynchronous processing that's running is complete. And I'll give a quick overview of this, and all the different examples are going to use the Async Tester class. So what we have here in the implementation is a list of suppliers to completable futures to void. And a completable future is just this really super cool kind of a proxy that allows operations to run in the background, and then it can have dependent actions dispatched when background operation or operation is complete. So we have a couple of methods here. One registers a supplier to a completable future to void, and we just add that to the test list. And we should also probably have a deregister method. I could easily add that. I just didn't think about it, but that would remove the element, the item from the async tester as well. For the purposes I'm doing here, I don't need to remove anything, but that would be a good addition. Here is how this thing gets used. There's a method called run tests. And what you do when you call the run test method, you want all the asynchronous suppliers that have been registered to all start running in the background. How do we do that, you ask? We use the stream method to turn the list into a stream. For each of the elements, which is a stream of suppliers to completable futures to void, we're going to call the get method on the supplier. That will invoke whatever it is that is doing the test, which will return a completable future to void. And then we're going to use something really cool here, which is our futures collector. We'll talk about that in a minute. And the futures collector is going to collect all the completable futures into one completable future such that when all of the completable futures that are running in the background complete, that one and only completable future will complete. So you're basically thinking about it as sort of it's kind of like select, if you're familiar with select in Unix, or wait for multiple objects, if you're familiar with that in Windows, where you can basically have a single object, in this case, a completable future, that waits for all the other asynchronous operations to finish. And when that happens, then we go ahead and print that we completed however many tests we completed. So that's basically the design of this particular helper. And let me show you how it gets used, because it's probably easier to understand it when you see it used in practice. So here we're going to run the thread tests first. And we're going to go ahead and create an async tester object. Then we're going to register this method that will do some testing using a thread. We'll talk about that in a second. You register another method that's going to do some running in the background using a thread. We register yet another method that's going to use a fork join pool. And once those things are registered, we call run tests on the async tester. And that will then start all those asynchronous computations running in the background. And then we have the one and only place in this test method that calls join. One of the very important things about completable futures is you really want to call join sparingly, because it blocks. In this case, we're blocking because we want to wait till all the tests are done. But normally you don't want to block very much. We just did this because we want to be finished with those tests before we run the other ones asynchronously. So all those things will go off and run in the background. All three of those tests will run in the background. And then when they're all done, join will return, and we print we're leaving run thread test. Now, obviously, I haven't talked yet about any of these tests. So we're going to do that in the next discussion. So we're back in our EX8 project, and the previous discussion had talked about the async tester and how that worked. You can go back and watch that part if you want to see what an async tester does. And what I was going to show here was how we use the async tester framework to register 3 method references that are going to do interesting completable future operations using explicitly created threads, not using the completable future factory methods to make computations run in the background, but to actually use the threads themselves. So to do that, let's go over here to the thread tests. And you can see this is just a little Java utility class. And it's got 3 methods defined in it. And we'll take a look at each one of them in turn. The first method is called test fraction constant thread. And here's what it's going to do. It's going to start out by creating a string builder object. And you'll see why we want the string builder, because we want to be able to store diagnostic information in a common place that can be printed out when we're all done with our asynchronous computations. Among other things, this will tell us what thread or threads the computations ran in. So here what we do is we make ourselves an empty completable future, which is a perfectly fine thing to do. And then we use a Java thread. This is just a good old Java thread, nothing asynchronous, nothing Java 8 about it, just a traditional Java thread, what would now be called a platform thread. And we pass it a runnable lambda. And the runnable lambda is going to tell this future complete with the results of a constant fraction. So here's the constant big fraction. This whole thing works off of something called a big fraction. Big fraction is just an infinite precision fraction, which you might want if you're doing some highly complicated math that requires large fractions. I use this mostly as an excuse to do some computations that take a while to run. Here is what the big reduced fraction future looks like. So the big reduced fraction takes the S big reduced fraction, and that is this thing. So this is going to be a big fraction that has a large numerator and a large denominator. Here is the large numerator, here's the large denominator. And so we go ahead and make ourselves a big fraction that's been reduced. That just means that it's in its reduced form as opposed to its improper form and so on. And this particular method takes that big fraction and it makes a completed future that when we join with it will just give us the result back. And I do this on purpose because your programming assignment requires you to do something along these lines. So I wanted to show you that technique. So that's what that thing is. So we take a big reduced fraction, we join it, that'll return instantly because we already calculated that value when we initialized it. And then we run a thread, we start a thread that will do that computation in the background. And then in the calling thread, we would normally do something interesting here. Right now, we're just going to basically append the string result here so we can figure out what thread this ran in. And we say future.join to mixed string, which creates the big fraction in a mixed form. So like mixed form would be something where you had, 2.5 instead of 6/4 or something like that. So then we go ahead and we display the result and we're done. So when we run this thing, you'll see what the results are, and it's kind of fun. Notice that this call to join won't return until the thread starts and we call the complete method on that completable future. So that's the idea of a completable future. You can wait for it to finish. Again, we don't want to use join too much, but this is a very simple example. So that's the first example here. Let's take a look at a more interesting example. This example is going to, once again, use just a good old Java thread, but this time we're going to make ourselves a completable future that's empty. And then we're going to create two big fraction objects, BF1 and BF2, which are initialized with these fields. And you can see we can put them in a format that is actually already a fraction if we want to. And then this particular thread, which will run in the background, of course, will call the complete method on the future after multiplying BF1 by BF2. So you go ahead and multiply those two things together, and that will then be done in the background. We start that thread, and then the calling thread says, hey, future, wait until the computation is done in the background, and then print the results. So that's the second example. You can see it's doing something a little bit more interesting in this runnable Lambda. But still pretty simple stuff. The third and final example in our kind of explicit threading tests is going to be even different. This time, we're going to create ourselves a callable. And a callable is an interface that's defined in Java 5. So it's been around for a very long time, almost 20 years at this point. And a callable takes no parameters and returns a value. So in this case, we're going to basically give it two big fractions using Lambda expression syntax. And we're going to multiply those things together and return that as the result of this particular callable object. We then come down here and we use the common fork join pool, which you should have learned about in the discussions of the parallel streams. And we submit that callable, and that will then go off and run in the background. And we get back a future, and that future it's not a completable future, it's just a future. And we will then call the get method on that future, and that will return a big fraction after this callable runs somewhere in the common fork join pool. So the common fork join pool will execute that, we'll get back the result. And so then when we call the result to mixed string, it should have computed and finished the background processing. So let's go ahead and take a look at what happens when we run this stuff. I ran this before just because it takes a while to run. So here are the results of the thread tests. You can see that the first one we did, which was the test fraction constant thread, it prints the results in the foreground, but the computation takes place in a background thread. And that happens for test fraction constant thread, test fraction multiplication thread, and test fraction multiplication callable. And they're all more or less doing the same types of computations. And we're getting back these mixed strings that take the fraction, reduce it, and then turn it into a mixed string. And you'll notice that all these things are all getting the return values in the main thread of control.